A lot of questions always arise when we're trying to set up the receiver modem selections. This is located from the keystroke of Charlie, Sam, Sam, Roger, and requires management level access to enter into. It's the receiver modem selection. Within this mask, we have the capability to set up all of the receiver inputs that are fed from the outside world into our SIMSII program. Typically, we want to set these receivers up so that they are at the primary system and that we can adjust the number. The standard configuration is shipped from SIMS. On the demo is 4, and for the initial customer selection is 10. But they have been modified and are easily modified up to a number of 24, I believe. Located within here, we're going to now take a serial input that comes in from the outside world and put it into the SIMSII program. The first thing we want to look at is the different field selections on here, and we can start out by looking at the port number. If I hit the page down key, I'm going to go to the second port. Page up reverses me back to the previous port. As we said on the demo that I'm showing you here, there are only 4-port capability, and I've addressed the first port for COM1 and the second port for COM2. Please note that on all NT environments, that's NT 4.0, XP, and Windows 2000, you may only use COM1 and COM2 for a DOS program such as the SIMS2. Now, the COM1 address is 3F8, but if I hit the F2 key, I can choose all sorts of other addressing, which would include the standard addressing that a lot of people use, base 100 digiboards and so forth. However, I can actually just simply backspace through there and put the address in there as I want. The second one is the IRQ. IRQs only pertain to those those boards that are ISA interfaced in. If you have a PCI type card, the IRQ has no effect, and you must then just use the addressing field to work with the PCI card. This type of change for the PCI card requires the SIMS support personnel to turn on something special in your program, so you're going to want to contact them. But again, you have an F2 key that you can go down and pick the different interrupts. The upper interrupts are obviously available. A is 10, B is 11, C is 12, and F is interrupt 15. Now the next field that is available there is the receiver type. If you hit the F2 key, there are some 150 protocols that are available to the SIMS2, even in the demo program. What you get in the demo program is identical to what you get in your larger system, with the only exceptions if we've made certain modifications for customer base or special receiver considerations. But if you receive your demo in and you're wanting to try something out with your demo, chances are you're going to get a very smooth operation right off the demo. As you can see, there are many selections here. Some of these we've tried to subdivide into special situations. Obviously, a Demco 685 is the standard configuration. /AUS happens to be for Australia, when the Demco contact ID first started sending in area information. So this selection makes us modify the codings and so forth like that. This was the 685 with partitioning. There were those 685s that didn't have the keep alive or the OK message going along, so we added a selection for that. And the Demco 8000, their newest receiver, well, the newest at the video work anyway, with the SKE format. There was the 900 megahertz radio, and the list goes on and on. We probably will just step forward here and pick up a couple of the others that are important to identify with. The DMP SCSI, that's the initial release out, and then we had a 2-user version of the DMP protocol that came out. There were no identifiers, so we had to put multiple selections in there so customers could select which ones they have. There are ESC direct wires, obviously. There are European ENI receivers. There's the FBI CP220. The /AUS again means that if the FBI receives it in contact ID, it's going to assign the user number as part of the protocol. There are Australian receivers, European receivers. We can actually step on down through here. There are just lots of ones to pick from. In the Osborne-Hoffman, you've got the Quick Alert with the UL, with the Osborne-Hoffman Quick Alert 2000. Lots of ones to pick from. Some of the very popular ones. In the radionics mode, you have 5 different settings for it. You have the original 6000 receiver, the 6500 protocol, which of course didn't support the area information, the 6600 protocol, which is the enhanced version and allows the usage of multiple types of formats coming in. The radionics version of the SIA protocol, a little bit different than SIA, and they used it specifically. They made some special changes in their protocol. There are multiple selections for SureGuard in here, another very popular receiver. The original Silent Nights are in here. We even have some special protocols that SIMS developed for those smaller type receivers that we're developing and so forth. Under the SureGuard, there are multiple selections in here. The original SureGuard DVAC. The most popular one and the one that most people choose is the MLR2 DG. Many of these are the same, but as they changed the names, we had to add some things here. The addition of the VONC protocol was done for Europe. Of course, there's the MLR 2000 and the SureGuard System 3. The SureGuard /AUS, again, that has to do with the contactee and the area transmission information, /no heartbeat, so forth like that. We go through lots of different protocols and modifications of those protocols. Some actually are modifications that are done within software, but we have lots of possibilities. You can try any of these when you're setting your system up if you wish, or if you wanted to take a demo and you want to try out a new receiver. This is the proper place to do it on a demo. Make sure that you're getting what you want and you can go forward like that. The baud rate settings go anywhere from 150 to 19.2. I'd like to recommend that you stay at the 1200 baud rate. The reason for that is 1200 baud, believe it or not, is very, very quickly. That's 1200 bits per second, much faster than the transmission. I believe most of the dialers that come in are 110 baud, maybe some are 150 baud, but they're very, very slow as compared to moving from the receiver into the central station software. If you choose very high speed protocols, the chances of overrunning UARTs, some of the computer UARTs out there that actually receive the universal serial async transmitter in, they may have buffering in there of 2 characters, 1 character, 16 characters. So if you keep the speeds down, since the SIMS2 deals with these under interrupt, the chances of ever having a problem are very, very remote. There are a couple of receivers that are set to certain baud rates. For example, the Osborne-Hoffman 2000 is set for 9600, cannot be modified, and they have their reasons for that. That's okay, but we're saying if you have a selection, I would recommend you stay down in the 1200 baud range. There's no sense going lower, but there's really no use in going higher. Data bits. Lots of receivers are set up with 8 data bits and 1 stop bit. Also, lots of receivers are set up with 7 data bits, 1 stop bit, and a parity bit. The parity bit is used to help define any kind of transmission errors from the receiver over to the computer. The SIMS2 software will monitor all of the parity bits and so forth like that, so you really want to use whatever your receiver is identified as. There are some mistakes on receivers out in the field. 8.1 will usually work unless you get involved in I have seen some receivers where they might have 7 data, a parity bit, and 2 stop bits. That's an unusual. That's an 11-bit transmission. Most are 10-bit, which is a start, 8 data, and a stop, or a start, 7 data, a parity, and a stop. but there are some that are 11-bit transmissions, so you really have to pay very close attention to what it is. 11-bit, of course, doesn't work through modems. There's lots of reasons why it should be 10 bits, but we're going to have to understand that there are things that we have to deal with there. The number of stop bits, we've mentioned that. There's usually one or two. I've never known of any exceptions to that. In fact, the protocol doesn't allow for any. Parity bits, we spoke about that briefly. You want to set your parity here. If you're completely uncertain, choose the 8-1 and no parity and see if you can get up on that. The way you'll know if your parity is wrong is you'll get constant interface errors. If your baud rate or parity is wrong, you're going to get constant interface errors. Now, if you go back to the display interface signals, which is from SIMSII main menu LI, and you can see your protocol coming in and it looks reasonable, then chances are the parity is wrong. If you see garbage coming in, then you should know the baud rate is wrong. Now, know that if you're dealing with a PCI card, the divisor for those baud rates is different than an ISA card. So we recommend that if you use a PCI card, and if you've had the selection turned on from SIMS personnel, and by the way, it's turned on in the demo, so you can always try the demo, you must use an address above 1000. If you use an address above 1000, then the SIMS program will know that it's a PCI card. We're talking about the address or port address. It will make the necessary adjustments in the divisor. Many years ago, before it was popular to have digiboard cards back in the early stage, and we're talking early 90s here, there were multi-port boxes that took 2 or 3 identical receivers in and then sent them through a single serial line over to the computer. These are multi-ports. This switch should always be no. I don't even know of a central station still utilizing off the top of my head. We have to leave that in there just in case there is, but we're going to say for the most part no. There is a receiver field here, which is an override for what comes in from the receiver itself. This receiver override, for example, we know that Tequila Willie's is 01, first 2 digits, that's this receiver ID here, dash 01, which is the line grouping we'll get to in a minute. But there are other circumstances now and other types of receivers, very popular in the SureGuard receiver, to where we would actually remove the entry out of this field and let the receiver number that is transmitted across in the protocol be sent on to the automation. And you simply do that by removing the override, and it will then take what it gets in and transmit it into the program itself. Also, there is a SIMS1 compatibility switch. Understanding about the SIMS1 compatibility switch, first of all, I need to give you a little bit of background. The SIMS2 was a complete rewrite or software upgrade, if you will, of the SIMS1. The SIMS1 was a product that had 2-digit zone numbers with modifier capability. The SIMS2 has 7-digit zone numbers with modifier capability. And so therefore, those people that upgraded from SIMS1 to SIMS2 and had all these 2-digit numbers in there, the 4x2, we had to maintain compatibility. So if you answer a yes there, all of your signals will come through as a 2-digit zone. That includes SIA, contact ID, Ademco high speed, etc., etc., etc. If you answer no, then it's going to transmit it in the widest possible protocol with a couple of exceptions. Modem 2 is going to be transferred for single and 2 digits the way it always was, which was a single digit or a 2-digit. If you want to modify that to some other, there are several available options in there. And as I recall, and you probably should consult your SIMS2 manual, we'll strike the F1. Yes, we have it in here. In the help screen, if you put a 1 in there, modem 2, 1 and 2 digits, troubles and restorals will be expanded. So you'll get a space T, space R, a space in the digits, whether they're 1 or 2 digits. This was done because, as we know, a lot of the radionics panels sent in different trouble signals that were actually test signals or system reset signals, and if we want to be able to deal with these across the board, it's necessary we have total programmability regarding these troubles and restorals. We'll also see that if you put a number 2 here, then all modem 2 signals are expanded. So it will no longer come in as just a code 1 or just a code 10. It'll come in with an A indicating its alarm on zone 10 or an A indicating its alarm on zone 1. These are very powerful switch changes here. So you want to make sure that if you're going to get involved in these, you may want to consult with the SIM support staff. You can always try it out. Just know that this is a global change and changes all accounts and has drastic changes on the database. A lot of times you can make that change to a 1 because you're only affecting the troubles and restorals, and they're going to be picked up by the zone accounts. But if you do the alarms, that means it's going to bypass all of the definitions that are located within your base account. Okay, the number 4 in there forces all SIAs to be 4-digit numbers. There are lots of circumstances. The SIA protocol capability allows you to set yourself up so you can have a account number 1, account number 01, account number 001, and account number 0001, so forth through the 5 and 6-digit account numbers. Knowing this, there are mistakes made out in the field, and a lot of central stations want to force those. Even if they set that account number to 5 zeros and a 1, they want it to appear as a 4-digit format, which would be 0001. So you can force those like that. This again is a global change, so just know that. That means if somebody sends in account number 123456, it's really going to come in as 3456. The lower digits are the ones that are going to be passed through. You also can put an S in there, which says convert all signals to the SIA format. This can be kind of nice, but again, it has tremendous effect on the way your database sits out there and what has to be done to your database for it to then be able to be matched up with the base accounts and so forth like that. So these are powerful things. They can be very, very helpful, but they just should be used with care. For 99% of the SIMS2 central stations, and a no in this field is really where you want to be. Now moving forward, we have the line card conversions. These line card conversions are group conversions. First of all, we always suggest that you set your receivers to transmit in the physical line numbers. Do not set the groupings inside of the receivers. For those of you who have a Demco receivers, if you pull out your line cards, you've got a little rotating switch there. Set those for exactly the physical positioning of the line card. This will allow the SIMs, first of all, to know what physical line the signals are coming in on, which can be very helpful in audio accounts and tracking down problems and situations. It also gives us the ability, when there's a line card failure, it means that we can illuminate the correct line card instead of all line cards being looked as 01, let's say. So for that, we want to let through the physical line numbers, and now we want to convert them inside of the SIMS2. In this case here, I've passed through those physical numbers, but let's just say, for talking's sake, that the first 3 lines were group 1, and the second 3 lines were group 2, and the second 2 lines were group 5. So now when I get a signal in on line number 1, 2, or 3, it's actually going to hit the SIMS database as line 01. This is the way you organize your groupings, and when I say groupings, we're talking about, in this case, 3-line rotaries together and so forth like that. Now, if you want your receiver to pass through the lines, let's say it's a SCADA coming through on a SureGuard from a remote location, you may want to remove these line card conversions so that they're passed through exactly the way they come into the receiver. Just know that if you do that, you have to go through a lot of considerations at a different time. Now, if you're involved in DNIS support, then you will not put any conversions in here. And when I say DNIS support, we're talking about the capability of the phone company knowing that when a certain line rings, it will send across a DNIS number that might be 0101, which is then passed through to the system as receiver number line 1. DNIS is very important because we've gotten involved in having to put in 40, 60, 80 lines into a central station in order to support all the possible formats, all the possible dealers. He wants his own lines. We have to make sure that we have plenty of rollover lines to get one through in our peak periods. Well, DNIS takes this away. We know, let's say for example, even if we have 50,000 accounts, at any one given moment during closing, we may be only using 15 of those lines. Okay. However, because of rollover capabilities of each one of these groupings, we may have 40 lines installed, which simply means to say that if I look at my different groupings, some groupings are going to be more busy than others. Some are going to be at that moment, while another might be actually creating a busy signal. Well, DNIS capability will then take, and those 15 lines can be looked at as an input of 8, 9, 10 different rotary groupings. And that's going to help reduce our cost. SIMSII, the compatibility of the SIMSII for DNIS support is there for most receivers, including the Osborne Hoffman 2000, the SureGuard, and so forth. Just know the receiver has to be DNIS capable, and we recommend, instead of us putting a table in for all these phone number possibilities, what you want to do is speak with your phone company, let them know if you receive a call into this grouping, you need it to transmit DNIS number XXXX. And they will do this. This is all part of what they do. It just means that they handle it at their end and you don't get involved. DNIS translation really probably belongs in the receiver. It definitely doesn't belong inside the automation software. Okay, there are a couple of other things I'd like to bring your attention to. Previously, within the SIMSII, we used this field to identify the group that came in. Well, that was all fine and dandy, but there were much better ways to use this for, so now we're using it for a timeout value. I can say that if I don't receive a signal for 30 minutes on this particular line, I want to create an operator event that will alert this operator that I'm not receiving any information in on that line card. The second line card, of course, I might set it for 45 minutes. The third line card, I might set it I might set it for every 2 hours. So this is the way we can monitor our lines. If for some reason I'm not receiving any information in there, it will bring it to the operator's attention by enunciate a signal to his screen that we have a line card timeout or a line timeout. And we can, of course, identify the phone numbers up here. DNIS support, of course, brings a whole new ball game to that, but not truly. While we don't monitor those lines before they hit the DNIS, we can also monitor the DNIS capability within here, knowing that this is really one grouping that is made up of many groupings, and so we can put our timeouts all the way down through that. Okay, this has been, hope this has been very helpful. I've enjoyed doing it. This should give you a much more in-depth overview of the receiver setups and the capabilities within the SIMSII. I'm going to just drop you back here, back a few masks for something else that's fairly important, just so we take a moment and take a look at this. I'm going to strike the F10 key. I'm going to back up here and stop by one other screen just to finish our understanding here. So we know what's going on. And here, this is display interface signals. This is accessed from LI. It tells me on port 1, it'll tell me what receiver type it is, and it'll give me the timeout values for each one of the lines if I have timeout values. Plus, I can use this to capture my protocol as it's coming in. In order to capture the protocol, I simply must go to the primary workstation, the one that's connected to the receivers, of course, and I can go down and select the receiver that I want. At that point in time, I can look for the signal that comes in, hit a space bar, and then I can do a print screen or write down what that protocol information is coming across. That's very, very important to assist SIMS support personnel to deal with receiver problems. We have all of the manuals for all of the receivers, but in today's market, with the way receivers open up portals to panels out in the field, they really can't guarantee what we're going to get in anymore. In the case of a SIA, that data comes directly through from the panel through a port right into the computer, and the receiver manufacturers have very little control over that now. That's a whole other subject about whether they should have relinquished that or not, but just know that there are many, many times we're going to have to ask for display interface signals if we're dealing with a signal type problem. Also note that a simple thing like a panel can come in any number of protocols, and some of these very sophisticated receivers like the SureGuards and the Osbornes and the Radionics receivers, some of these others. These are sophisticated receivers capable of receiving sometimes 25 and 30 different protocols, of which SIA might have 7 or 8 different types, just to give you an idea. So there are many times it's extremely necessary we get that. We're going to have to ask you for it, and we do want you to know that we appreciate it when you take the time to do it. If we could reach out somehow and do it, we would. Okay, thank you. This concludes our set receiver modem configuration video.